gave you has 12 little pictures. So it's very similar to what we were looking at in the examples that you have in Blackboard. So when you look at this one right here, it is very similar to either this little picture right here or this little picture right here. What we've got are 12 instances of an I shape. That I shape is either laid on its side like this with numbers 1, 2, 3, 4, 5, and 6, or it's turned in this position on 7, 8, 9, 10, 11, and 12. The next page is where you will do some fill in the blanks. Like I said, we're learning about the fill in the blanks and what goes in there. Yes, sir.
Is it due Monday or Thursday?
Thursday at the earliest. So we'll see where we finish up tonight and what all we talk about Monday night, and we'll go back to this a little bit Monday night also. But yes, Thursday night at the earliest. And what time do we need to leave? Yes?
8:15.
8:15, so y'all heard it, 8:15 we need to be.
Okay. Let me read.
So that's my target time.
Thank you.
So on this page, like I said, we're just looking at this very little picture right here. And we're gonna go through, so all we've talked about right now is the number of rows. So in this position right here, similar to what you have on that handout that I gave you, the second sheet. The second sheet shows just this end. And it shows, I believe, that measurement down 3 inches to the first hole. Yes, it does. So none of these are W8s. And then what I show is the top hole and the bottom hole. So if you look up the member and it is a W10, and you go back to that chart that says number of rows, and you look on that number of rows, you're gonna see that a W10 holds 2 rows. So if it was a W10, you would just put a 3 between those. To blow it up, what you're looking at right there, see how clear that is? So what you've got there is kind of like what I have here. You've got a beam, and it says from the top of that beam down to the first row of holes, and I gave you that dimension of 3 inches. And then I came down here and I said, all right, here's the last hole. And I did not give you a measurement. So if you look it up, and it is a W10. W10 only has 2 rows. So when you fill in this dimension, it's gonna be 3 inches. That is what you would fill in for that number, telling me that there is only 2 rows on that member, because there's 3 inches one time. 1 row and then another row. If the member that I give you is a W18, you're going to come back over here. You're going to go to that chart and you're going to say, well, here's the W18, 3 rows. Let me look at the next one. Here's the W18, 4 rows. Let me look at the next one. Here's the W18, 5 rows. Let me look at the next one. No W18, so that one has 5 rows. So you're gonna say, well, Mr. P gave me 1 row, 2 row, 3 rows, 4 rows, 5 rows. What's our distance between these? 3 inches every time.
So we gotta use this sheet to work this one? Is that
Correct.
Okay.
So
So
when it's
one,
on one
Oh, go ahead.
Those two sheets go together. Yes, you need to draw the lines and show me how many threes there are. Don't just give me the overall dimension. Don't just say from that first hole to that last hole is 1 foot.
Do you want us to draw on the actual,
The handout I gave you, yes.
on the second one?
Yes.
Okay.
And the second one is the only one that you'll be turning back in.
Okay.
In your
So this is
notebook,
just rough.
in your notebook, I think this might be like a professionalism grade. But this would be one of those instances to where, once you know what section it goes in the notebook, both of these sheets would probably need to be together. If you go back to study it 2 weeks from now, 3 weeks from now, you're studying for the final, you would want those two sheets together so you could study stuff like that logically. You wouldn't say, well, the first sheet's just a handout, so let me stick it up here in the handouts. Let me stick this one back here in the assignments. So just little things like that. However you do your notebook is up to you. But you will only be turning in the second sheet. And you will be filling in the number of rows right there. So just like I did in blue right there, you will be doing. This measurement right down here. So on your project that you got, you're only looking at this area, but you can see that that right there is one of the things that you're looking at. Let me go ahead and open that up. Because there is something else that we've already talked about that you could be looking at now. So I'm gonna go over it real quick. So this is your first sheet that you received. This is your second sheet. So if I zoom in on one of these, I believe on that first sheet, so that first one up here is a W12 by 26 going into the flange of a 14 by 48. Let me draw that up here. The column is a W14 by 48. The beam is a W12 by 26. So on yours, you will say, well, W12, you look on that page, it has 3 rows. There's 1 row, there's 2 rows, there's 3 rows. There's your measurements for it. The next thing is we're attaching to the flange. So we know that on this one, the dimension would go to there. Like I said, on that general notes, it tells you some of this info, but a column is always dimensioned to its center. In either direction, it's always going to be measured to the center of that member. So that dimension right there, we know that we would have to subtract that number right there, just like that 2 inches up there. So that is a W14 by 48. So nominal depth is W14, but we're not just gonna say 14 divided by 2, 7 inches. We're going to look that number up. So whether it is on your slider or your wheel, a 14 by 48, the depth. So the depth of this member is 13 3/4. That means for this number right here, you're going to divide that by 2, and you will write 6 7/8 for that. your overall depth of that beam, the overall measurement of that beam, because remember, our main dimension comes from the center. So here's my column right here, this I shape right here. My dimension would be going to there, so our minus dimension is half of that, which would be half the depth of that member.
And then we subtract the 1/4 inch, right?
What?
Do we subtract the 1/4 inch? So count for the
No,
inch?
ignore that.
Okay.
Yeah, ignore that. What that 1/4 inch, because that probably just got y'all wondering about it. What that 1/4 inch is none of your business. So, on this up here, what that 1/4 of an inch is, that's where I said that one that they had me doing the plates on the end was more expensive than doing the clip angles. It's not talking about how much this piece of material costs. These angles versus that piece of plate. What cost more is this piece in between them, this beam across here. Because to put these clip angles on the end and hold that beam back 1/4 of an inch, you know, if the guy that's cutting beams that day, if he got his tilt on last night and that beam isn't totally square, it's okay, because they're gonna set that member down like this. They're gonna put those angles out the end. They're gonna hold a square on it to make sure that they're the right measurement out and that they are flat across and up and down. They're gonna put a square and a level on it, and they're gonna say tack, and they're gonna tack some weld on there. So this beam doesn't have to be cut 100% clean, straight up and down, 100% cut, which means it can be done by a person with a cutting torch and a grinder. Whereas to put that plate on the end, if this beam isn't cut 100% straight up and down, square right there, then that plate on the end can be tweaked or leaned, which means it's not going to go up to that member flat, because that plate might be kicked out a little bit. So that cut costs more. If they're gonna put that plate on the end, this has to be 100% plumb right here. There has to be nothing but squareness on this end, or that plate is gonna be off a little bit, and it's gonna make that member, once they bolt it up, it's gonna be tweaked a little bit. They can't have that. So that cut costs a lot more. That cut is probably gonna be done by some kind of a machine versus the clip angles. So what we do is we have a standard, we're gonna hold it out 1/4 of an inch. We're gonna let those clip angles stick out 1/4 of an inch. That way, in case the beam cutter, like I said, got his tilt on a little bit last night, and the actual end of that member is right there, that's okay. They're gonna square up those angles on the end, and everything's gonna be good.
Am I tripping, or did you say that we're only going up to 5 rows?
Up what?
5 rows?
It all depends on the member. So
you
this
know-
one has a W12. So we look on that sheet, the beam row connection chart, the highest, so remember, we want the maximum number of rows. Hey, Coop, can y'all can y'all put it back on there to open the doors up, please?
For Thursday?
Yes, ma'am.
Okay, cause I know the other security officer that come before me was supposed to do
Really? Yeah, I'm back to Mondays, and I'm still Mondays and Thursdays.
it. Okay,
Spooner, his class made last night, so he's Monday and Wednesday still.
okay.
But he gets here in the middle of the day.
Saturday, are y'all doing y'all full?
Yes, ma'am. I got
okay.
Saturday also.
Okay,
It's long,
and what time?
9 to probably about 2:30 or 3.
Okay.
Alright,
Alright.
have a good evening.
Y'all too, have a good one.
So on that particular one that we're showing up here, number 1 on that first sheet showed a W12. Remember, it's the beam, that single line coming off the I shape that we're looking up the rows. That's the beam. Remember, this is looking down on it. So when we're looking down and that member that has a name, W16 by 36 or something, that's looking like this, it's shaped like an I in one of these two positions, that's the column. That's not the one that sets the number of rows. Because this dude's up here like this. We could put row after row after row in this thing because it's standing up there. It's that other one, that beam that's attaching to it that says, I've only got this much room. If you go down 3 inches to the first hole and 3 inches in between them, I've only got this much room. That's what sets the number of rows, the beam, not the column. So going back to that other sheet. On this one right here, you're gonna look up the 12 by 26. That sets the number of rows. Over here, the 14 by 48, that sets the number of rows. Over here, W18 by 35, that sets, so these are the beams. Those are what sets how many rows there are. These are the columns. That's where that minus dimension came from. I said, well, I'm designing the end, I'm detailing the end of this one. I've got a measurement that says from here to here is this long. And I gotta tell them to cut this much on that end, which is our minus dimension. Then I'm gonna do the same thing on the other end, and I'm gonna do the math and tell them how long it needs to be when it goes out of the shop to just drop right between those two columns and bolt up. So a lot of it is visualizing, being able to look at it and visualize and understand what we've got. I'm not gonna get into center to center gauge tonight. That's these next components, and that's where it gets really deep. Right now, just kind of think about it and focus on that. Because after that, that's when we start talking about sometimes the column, sometimes the beam. But for right now, just kind of think on that and try to get your equipment by next week, which, like I said, the calculator, if you want to get one on your phone right now, just one of those free apps, do one that does the feet, inches, and fraction calculator. Imperial units calculator, not just a general calculator. Can you use it? Yeah, but that's where you have to get those charts involved, those decimal equivalents involved. So if you don't want to do that, I recommend you just see about getting you their free apps, and then make sure that you can correlate that to something that you can find on the computer for test time. So here in probably 2.5 weeks or so, when we start talking about having the first test, just covering stuff like this, this is the basis of it. We got to be able to look at that drawing and say, this is what's happening. This is what I need to do. Do I need to add, subtract? How do I find so that when these two pieces get out there inside this refinery, possibly in another state, in another country, and I'm not just a phone call away, I can't just walk out to the shop and say, okay, this is what that drawing says. That's the way we have to have it when it leaves our desk as a detailer. That's where the drafting needs that drawing to be. So just absorb that and see about getting your will and getting access to a calculator. All right, so nothing's due yet. Any questions? Let me check roll. What you got?
I do. What time do we start class then on Monday?
5:15.
Be here at 5:15?
Yeah, I won't be here till 6 to start class, but you need to be here about 5:15 because you need to go find her and get her to come open the door.
So at 6?
6 o'clock, yes, sir. All right, y'all let me check roll real quick.